Hello everyone. So the next topic in the semiconductors is the energy band diagrams. Okay, this comes under the field theory subject. Okay, so here what is meant by energy band diagram? So by now when you're seeing this video you should be able to know about what is meant by conductor, insulator and a semiconductor. I'll just brief you. Conductors are nothing but which will conduct electricity. Insulators are nothing but which will not conduct electricity. Semiconductors are which will act like a conductor as well as an insulator, okay, based upon the temperature. So now we'll see that how these will have the energy band diagrams. Okay, so the difference in this electrical behavior of good conductors, insulators and semiconductors can be beautifully illustrated on the basis of energy band diagrams. Okay, so like I said, some materials will take electricity, some will not allow the electricity to pass through this and all. Why those few materials are able to take electricity, why other materials are not able to take electricity and all, it basically depends upon all the kind of atoms we have. Okay, so generally what happens is, so all matter whatever is present in this universe, it is made up of these atoms. Okay, generally in any atom there is one nucleus. Okay, the center part, there is one nucleus, and these electrons will be revolving around this nucleus, okay, in several different orbits. There are different orbits also. Okay, so the nucleus is composed of mainly protons and neutrons. These protons are nothing but a positive charge particles. Neutrons are negative, no charge, sorry. Generally, the mistake what I have said now, generally most of the students make this mistake that neutrons, by the name itself we think it as negative, but that's wrong. Neutrons have no charge. Okay, neutrons means no, and electrons have negative charge. Okay, so the charge of electrons E is 1.602 into 10 power minus 19 coulombs. Okay, I'll draw in a diagram and show you what exactly I was reading above. So suppose this is an atom. Okay, suppose this is an atom. So this will be the nucleus of the atom. Okay, so nucleus is nothing but there will be some center part, and this around there will be some orbits. Okay, based upon the atomic numbers and all, these orbits will be designed. Okay, so we'll see, like for example in the first orbit there will be 2, and again here there will be 4 somewhere. Just imagine our solar system. Okay, the center part is the sun, that means the nucleus, and the earth and other planets, Jupiter, Saturn, everything revolving around it. So this is the concept actually in the solar system also. Okay, so this is, I'm just telling you that as an example. Okay, so these electrons will be revolving. So like I said, in the semiconductors or any materials, a flow of electrons will be there, electricity will be there, right? So these electrons will be moving randomly here and there. So when supply is given to this some atom, all this, not only one atom, if there is silicon there will be numerous number of silicons, right? So these atoms will align themselves, they'll be moving randomly. This electron flow will be taking place among all other atoms also. So that flow is called as electricity. In some materials like paper, wood and glass, or some kind of mica, in those kind of things the atoms will be random. So even though if you give supply to that, it will not be affected. These electrons will not align themselves, so there will be no flow of electricity in it. Okay, so that's why those are called as insulators. I hope this is clear. So this is so the nucleus, yeah, inside the nucleus will be having this protons. Inside the nucleus there will be protons and neutrons. Protons are positive charge, neutrons have no charge, and electrons, all these electrons will have negative charge. So the total number of electrons in an atom depends upon the atomic number. So like I said, the electrons will be randomly spread, right? So how that number will be, how they will be spread is based upon their atomic numbers. Okay, for example, oxygen, the atomic number is 8. I think you know the if you know the atomic periodic table chart, right? So those where there will be having these atomic numbers. So like that you can know the number of electrons also. Okay, so these electrons will be distributed in several orbits or shells around the nucleus. I showed that orbit, right? So these electrons will be surrounded around that nucleus. So these number of electrons which can be accommodated in a shell is fixed, and it is given by 2n square. So this point is very important. Okay, now we are telling that around the nucleus in the orbit these electrons are rotating, right? So this orbit, how many electrons should accommodate in that orbit? It will be it is fixed, it will be known by this 2n square. Okay, n is a shell number. If it is the first, for example, I'm just drawing here, this is the nucleus, this is the orbit. Okay, this is the first one, right? If this is first one, then n is 1, so that will be 2n square is 2 1 square, that is 2 into 1 will be 2. So the number of electrons that can be accommodated here are somewhere here 2. Okay, again third one, so that third is nothing but n is equal to 2, so 2 square is 4, 4 into 2 is 8, then it can accommodate 8 electrons. So that's what here I'm giving it as an example. So the first orbit can accommodate 2 into 1 square, like I said, that is 2 electrons. Second orbit, 2 into 2 square, 2 into 4, that is 8 electrons. Again this is the same thing in the third orbit. So the maximum will be 18. Okay, as atomic number increases, the total number of electrons in the atom increases, hence there will be more number of orbits. Yeah, if we go to 32 number atomic number of some atom, so obviously the number of orbits will be more, because the number of electrons are more. Automatically the number of orbits also will increase. So the last orbit, that is outermost orbit, is limited to 8. See here, these number electrons values are increasing. The orbit numbers what we are taking here, 4 square, 5 square, you can take till maximum is 8. Okay, till 8 square, 8 square into 2, 64 into 2. Okay, 64 into 2 will be 8, 128 electrons can be accommodated in the last orbit. So this is the maximum one, the last one is limited to 8. Okay, so the outermost orbit, like I said, will be having the maximum number of electrons. Okay, so that is the outermost orbit will be 8. Okay, so this orbit, the last orbit, the outermost orbit, is called as valence orbit. Okay, and the electrons in that last orbit are called as valence electrons. Okay, you should be very clear what is meant by valence electrons is nothing but, by the name itself you remember, valence is nothing but the last one. Okay, the last electrons in the last orbit is called as valence orbit or valence electrons. Okay, so an electron in any orbit of an atom has some energy. Okay, like we said, electrons will have some energy, right? So this energy will be increasing when the distance of this orbit also increases from the nucleus. So the last orbit, okay, for example the 8th or 7th orbit, so the more the distance it will go away from the nucleus, the more the energy it will possess. Okay, so as we said, the maximum is 8th one, and that is called as valence electrons and valence orbit. So in any atom, the valence electrons possess the greatest energy, that means the maximum energy. Okay, so this range of energies possessed by electrons of any orbit, like first, second, third, of all the atoms, are referred as energy band. I think now it is clear that by the name. So energy band is nothing but this range of energies possessed by these electrons in any orbit. Okay, first or second. So these atoms are called as energy bands. So yeah, the energies which these electrons hold in each the orbits are called as, those orbits are called as energy bands. Okay, so the energy band in relation to valence electrons is termed as valence band. So the valence electrons, so the outermost orbit, for example, for any atom, if the outermost orbit is 4, okay, the maximum is 4, so those electrons are called as valence electrons, and that orbit is called as valence orbit. Okay, so that energy band, whatever is present in that atom till the valence electrons, so that is called as valence band. So the valence electrons, okay, possess the greatest energy since they are farthest from the nucleus, and they are least attracted towards the positive charged particles. Okay, positive charged particles are nothing but the protons. Okay, these protons are present in the nucleus, right? So towards the nucleus they will have less attraction. Okay, because they are far away from the nucleus. Okay, this is so because there are negative charge electrons in the intermediate orbits, and these electrons exert a repulsive force on valence electrons. Okay, so like I said, in the nucleus positive charge is there, and these valence electrons are in the orbits, right, in the away from the nucleus. So these electrons, what charge they have? Negative charge, right? So between these two, positive and negative, they will repel each other. There will be some repulsive force on this valence electrons. Okay, so because of this, the result is these valence electrons are loosely held to the parent atom, and in a metal they move about freely within the material. So this is what happens. Okay, in metal is nothing but a conductor, right? What happens in conductor is, I'll just draw and show you in for easy understanding. Okay, like I said, this is the nucleus, right? In the nucleus we have protons. Okay, protons, positive charge, and neutrons. Neutrons has no charge. Okay, no charge. So these are the orbits. So all the electrons are here, somewhere randomly here and there. Okay, so suppose this is the highest orbit, so the electrons here, these are called valence electrons. Okay, so and this orbit is called as valence orbit. So here this, whatever we are calling this, for example, some more, I'll draw some more. Okay, if this is the maximum one, this is okay. Here this is the nucleus. So the attraction of this electron towards this nucleus is this distance is very far when compared to this, right? So this is very far, and also there will be a repulsive force here because these are negative charge and this is positive charge. It will repel each other. Okay, so because of this, the outermost orbit electrons are, they will be rotating freely here and there because they'll have no control on this one. They are loosely connected to the parent. Parent is nothing but this one because they are far. Okay, so whenever one more suppose some other atom is there here, and some its outer shell also some electrons are there. If this is also rotating, if this electron will get sufficient energy so that it can jump here, if it will get it, so the outermost orbit of this one, this electrons only will jump here. Okay, so this will get the energy. So again, if there is one more atom, it will jump here. So in this way they will align themselves. That is nothing but this is called as the flow of electrons. This flow of electrons from this part to this part, and this electron will jump here. Again one more will come here. So this flow, whatever the flow of electrons is going on, no, so that is called as current. So this, based on this current only, no, we are differentiating conductors, insulators and all. Okay, so this freely moving electrons are maximum in conductors. In insulators this is not present, so they will not conduct only. And in semiconductors, sometimes based upon the temperatures, these will act like conductor or insulator. I think in the flow of electrons is this. Okay, now coming back here. Yeah, so like I said, the result in valence electrons are loosely held to the parent atom, and in a metal they move freely. Okay, if sufficient energy is supplied to them, they get detached from the parent atom. Like I said, they will detach from here and they'll jump to the another atom. So electrons which are removed from the valence orbits of atoms are termed as free electrons. Like these one are called as free electrons. Okay, it is these free electrons which constitute the flow of current on application of voltage. So the range of energies by free electrons is termed as conduction band. So these free electrons, whichever are moving here, if some voltage is given to this, so they will align themselves in this flow of electrons takes place. So then this band, okay, this band is called as conduction band. Okay, like I said, this is called as conduction band. Okay, like I said earlier, so electrons in the last orbit are called as in the valence band. So when it gets detached from the atom, it becomes free electron. Okay, and it will enter into the conduction band. So when it is entering from that place from the plans, there will be some gap here, right? If it is jumping from here, that gap separating conduction band and valence band, that means no electron can exist in that void. So that is called as forbidden band. Okay, I hope when that electron is jumping from this band to the another band, it is coming to conduction band, and another electron cannot fill that place exactly over there. That means there is some void gap. That void gap is called as forbidden band. Okay, I hope it's clear what is meant by conduction band and forbidden band, and all the energy band diagrams of this one will be seen in the next next video. Okay, just metals, how we draw the energy level. In insulators and semiconductors we can see in the next video. Thank you. Please post your questions in the comment section. I'll try my best to help you out, and also let me know if any other topics you want to know. Please write it down. I'll try to explain it as easy as possible to you, so that it's very easy for you people to understand and remember for a longer duration. Thank you. Bye.